In this video, I am going to cover the OSI model. The Open System Interconnection model, OSI, is a 7-layer model used to visualize computer networks. The OSI model is often viewed as complicated and many fear having to learn the model. However, the OSI model is an extremely useful tool for development and problem solving. Each of the 7 layers goes up in increments of 1 as it gets closer to the human user. The application layer is closest to the person, while the physical layer is where the network receives and transmits raw data. In plain English, the OSI provides a standard for different computer systems to be able to communicate with each other. The 7 layers of OSI model are the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. The 2 layers, session layer and the presentation layer, are extra in the OSI model as with respect to the TCP/IP model. This is how you send a message to a friend. I would like to demonstrate with an example. Firstly, you want to communicate with your neighbor system. You need a physical connection. It is cables coax, the physical layer. Even though you are connected physically, you need to address yourself. That is MAC, the data link layer. MAC is a physical address for your device. Basically Ethernet, Wi-Fi, etc. Now you have a MAC and a physical connection. All you need is logical address, that is IP, the network layer. Now you have a good setup of network with physical links and addresses. But how do you communicate? All you need is a protocol which transfers data from your system to another. That is the TCP or UDP, the transport layer. There should be an intermediate node which manages the setting up and taking down of the association between two communicating endpoints, that is called connection. That is done by the session layer. The data flows in a network will be in the form of ones and zeros. So there should be a node which translates the ones and zeros to plain text, that is the human readable format, and if necessary, compression and decompression. This is done by the presentation layer. Finally, what you see in your monitor or mobile is the final application and the result of the combination of all these protocols. This can be done by the application layer, the HTTP and the HTTPS. The first 3 layers are responsibility of the network, and the next 4 layers are the responsibility of the host. The layers of the OSI model. First comes the physical layer. The physical layer is literally the physical hardware that makes up the network. This layer has several major functions: defining physical specifications, defining protocols, defining transmission mode, that is half duplex and full duplex, defining the network's topology. Hardware such as the physical components of the Ethernet cables and the Bluetooth are just some examples of the physical layer. This is also the layer where the data gets converted into a bit stream, which is a string of ones and zeros. Generally in computer system, 1 stands for true and 0 stands for false. The next comes the data link layer. The data link layer is very similar to the network layer, except the data link layer facilitates data transfer between 2 devices on the same network. Data link layer is where switches operate and provides a reliable link between 2 directly connected nodes. Data link layer is also responsible for detecting and possibly fixing any packet errors that may form on a physical layer. Next comes the network layer. The network layer is responsible for facilitating data transfer between 2 different networks. If the 2 devices communicating are on the same network, the network layer is unnecessary. The network layer also finds the best physical path for the data to reach its destination. This is known as routing. This is where your IP address comes from. The router is responsible for sending packets of information out into the internet and then receiving them. These packets' origin and destination is determined by the IP address of your router. The next is the transport layer. The transport layer is responsible for end-to-end communication between 2 devices. As I've shown the truck between the 2 devices. The transport layer is responsible for the logistics of the session. The transport layer would be responsible for determining what and how much information is transferred between the operating system and the web server. Next is the session layer. This is the layer responsible for opening and closing communication between the 2 devices. The session layer is responsible for creating and maintaining sessions between the operating system on the presentation layer and the other third-party machines. For example, when a user is browsing the internet, they are interacting with the application layer. The application layer is interacting with the presentation layer, and the session layer allows the operating system to interact with the web server. Yeah, this is a bit complex thing. The session layer ensures that the session stays open long enough to transfer all the data being exchanged and then promptly closes the session in order to avoid wasting of resources. The sixth layer is the presentation layer. This layer is primarily responsible for preparing data so that it can be used by the application layer. The presentation layer is also responsible for translation, encryption, and compression of data. The presentation layer is where the operating system lies. This operating system could be Windows, OS, or any Unix-based operating system, or one of the many applicable. When the human user interacts with the application layer described above, the application layer interacts with the presentation layer. If the devices are communicating over an encrypted connection, presentation layer is responsible for adding the encryption on the sender's end as well as decoding the encryption on the receiver's end so that it can present the application layer with unencrypted and readable data. This is the most important point of the presentation layer. The application layer. The application layer is where the user inputs data and data is output to the user. Software applications like web browsers and email clients rely on the application layer to initiate communications. But it should be made clear that the client software applications are not the part of the application layer. Rather, the application layer is responsible for the protocols and data manipulation that the software relies on to present meaningful data to the user. Client software is a specific application that's installed on your computer that can be used to communicate to some other piece of the software over a network, such as Internet's World Wide Web. Microsoft Outlook on your desktop is a software client, and indeed web browser are software clients. An example of the application layer is an internet browser, an FTP client, or even Microsoft Word. The advantages of OSI model. OSI model breaks the complex world of networking into a single model. OSI model is basically a generic model, and that is including a whole group of things. OSI model is a well-distinguished model, that is, all the layers are well distinguished and separated. Supports connection-oriented and connection-less services, more secure and adaptable. The disadvantages of OSI model. Basically, it is a theoretical model which does not guarantee efficient technology. Inadequate solution for practical network implementation. When OSI appeared, the TCP/IP protocols were already implemented. This is the main disadvantages of the OSI model. The layers cannot work in parallel.